Okay, so this is the ray diagram video for the final. I'm just going to walk you through how to draw the 3 different ray diagrams. We're going to start with a converging lens where the object right over here, okay, this guy, is outside of the focal length. This is the one that we did in the original day that we did the ray diagrams. The first ray we typically draw is perpendicular to the object, so parallel to the axis, and then it is going to hit the lens and go down through the focal point on the other side of the converging lens. The second ray is what we call a central ray, and it goes right through the center of the lens and the axis. Now obviously if these lines don't perfectly match up here in the corner, in the area over here, if they're not perfectly lined up, it's going to make a difference in how well they line up at the end. Alright, and the third one, it goes through the near focus like that, and when it hits the lens it comes out parallel. And you can see I'm a little bit off, but I've got a little bit of wiggle room. Let me move that out of the way, because really that should be up there. That's a pretty darn good spot. To finish my problem, I'm going to draw an arrow that looks upside down, meaning this has gotten flipped upside down, and it is a little bit shorter than it was before. And there's your converging lens with the object outside of the focal length. I'm actually going to jump to a converging lens where the object, okay, right there, is now inside the focal length. So because it's inside the focal length, some weird things are going to happen, okay? For instance, to start out, we always start with that parallel ray. At least that's how I start. Oops. Let's go ahead and draw my parallel ray right here. When I get there, I'm supposed to go down towards this focus here, which is true. I do. And then I'm supposed to have one that goes through the center, which I do. And then I'm supposed to have one that goes through this focus that's behind me. Well, I can't actually go through that focus, and so what I'm going to do is I'm going to follow the focus back up this way. Okay? I'm going to run out of room on this drawing. See, the problem is they don't actually converge. It actually looks like they're diverging, and the reason why is because when we get inside the focal length, it actually magnifies things and brings them close to our eye. So with this type of a setup, we actually need to backtrack these lines. So if you can think about going backwards here, okay, trying to follow the same line. I mean, I'm not perfect at it. I'm trying to follow the same line. And then if I did it again for this one, I'm going to start here, kind of just follow. There we go. And you see they're going to meet way back there. Whoops, what happened? Oh, I clicked something else. All right, let's try that again. Okay, it's going to come out like that. And I didn't do a very good job of this, this other one. Wherever it hits, it would come back out parallel. You know, when something goes through a focus, oops, let me get here. When something comes through a focus, it's supposed to come out parallel. Now these would all meet up somewhere back there, and that's where I would draw my object. Clearly, it's gotten much bigger. That's what we call a magnifying glass. That's why we call it a magnifying glass. And it's also brought closer to your eye, which is great, so you can examine it a little bit better. So there's the concept of a magnifying glass. The rules are the same though, guys. Starts out parallel, tries to go through the focus. It does, but what ends up happening is that light gets brought back together up higher. We have to backtrack when they don't meet. Same thing here, the central axis is never going to meet. Those don't touch each other, so you got to go backwards to find where they meet. And of course, you just follow the line of the focus and come out parallel, and you'll meet up in the back somewhere. That's just, I ran out of space, so I'm sorry about that, but it's what happens when you use technology. I don't have a page quite the size I should have when I started this. At any rate, we're going to go through the diverging lens now. Diverging lens, remember, follows the same rules, same types of rules anyway. We're going to follow that parallel line. Whoops, did not mean that. Let's go back. Let's get rid of that. Alright, so we're going to follow that parallel line out to the axis, to the lens, and then instead of going down to the next focus, it's going to appear as if it's coming from the focus behind. So it's going to do that. Okay, so it's going to bend away from the center or the focus. All right. The next ray of light is the central ray, and it never gets deflected. Just goes straight through the center. And then the last ray is the one that's going to try to come through the far focus. It's going to aim for way over here. Okay. The problem is that as soon as it hits the center of the lens, it gets deflected and goes out parallel. So the part of the line that's right here doesn't actually occur because it gets bent. Okay, so now if we try to backtrack this dotted line, I'm going to take it, hold on, let's see if I can grab the right one. There we go. If I backtrack that, we'll notice that all three of the lines meet right there. And there's my new object, or my image. It's smaller, but it is close, and it's closer to the lens. And that's what a diverging lens does to us. Well, what happens when you put a when you do a diverging lens with the object inside the focal length? Well, the good news is it's all the same thing, basically. Let's start with the simple one. We're supposed to go like this, and then we are going to bend down towards the, we're going to come from this left focus here. All right, just like we did before. It's going to seem like it appears going up that way. Then we have our central ray. And then we have our ray that's trying to get over to here, but as soon as it hits the center of this there, it starts to go that way. So let me reposition that just like that. Well, I'm going to have to backtrack that. And in so doing, I find that there is my image. Now you can do all three or all four of these using the equation 1 over dO plus 1 over di equals 1 over f. Couple things to keep in mind. F is positive for converging and negative for diverging. And then dO and di, okay? dO, we're going to pretty much, because of the way we're going to structure it, we're going to consider it positive unless using two lenses. Now, if you use two lenses, it still might be positive, but you have to look at, is the object on the same side that the light is coming from? If it is, then it's positive. If it's negative, that would be because it's on the same side as the light. It's opposite side of the light's coming from. And then with the image, okay, if it's on the right, we expect it to be positive. If it's on the left, we expect it to be negative. So for instance, if I did the formula here, that would be negative. On the other ones, this would be negative for image distance. This would be negative for image distance. And this would be positive for image distance. I hope you can walk your way through those, replay them, slow it down as much as you need to, come in and ask your questions, but good luck, and we'll see you in class.